The property graph abstraction, popular for modeling relationships between real-world entities, utilizes Neo4j as a widely adopted database. In this data model, nodes represent entities while relationships depict connections between them. Node labels and relationship types and properties store additional information. However, query languages such as Cypher and PGQL pose challenges for non-programmers due to their syntax and semantics. A visual abstraction called labeled atomic graph, LAG, has been used traditionally. Yet, LAG's textual labeling of predicates on nodes and links can clutter and reduce aesthetics. LAG also lacks effective visual cues for predicate properties. Moreover, LAG operations cannot optimize shapes and sizes to convey information. With uniform node and edge sizes, determining predicate numbers through visual inspection alone becomes challenging. In this video, we present Sierra GUI, an innovative interface for visual property graph queries based on LCG. Sierra comprises 3 panels. The left panel displays a list of node labels, relationship types, and associated properties. The middle panel allows users to construct read-only Cypher queries visually through direct manipulation. The right panel provides a real-time display of the corresponding textual Cypher query for the constructed visual query. Sierra GUI is designed based on labeled composite graph, called LCG. Unlike LAG, it utilizes HCI, psychology, and visualization theories to create a visual abstraction of property graph queries. Now we will see the novel features of Sierra guided by these principles. From psychology, we accept Gestalt principles, visual complexity theories and principles, as well as Berlin's aesthetic theory. Guided by Gestalt principles, Sierra uses a colored circle with smaller circles on its circumference to represent nodes and associated properties, and directed edges are overlaid with sets of color-coded circles representing link predicates. Node labels, properties are aligned and grouped together in the left panel. Based on visual complexity theories and Berlin's aesthetic theory, the LCG abstraction adds a moderate degree of visual complexity that has positive impact on aesthetics. Details of predicates, node label, relationships are exposed on demand with a consistent text format and color. From HCI, Schneiderman's golden rules are adopted. Based on the golden rules, Sierra provides list of nodes and relationships, property map, and possible target nodes so that user can choose them instead of manually entering the data. From principles of visualization, Sierra follows expressiveness, effectiveness criteria, and principle of importance ordering. The representations capture exactly the facts and uses color, position, and shapes which are high-ranked in perceptual tasks list of nominal data type. Area is used to convey relative differences in the number of predicates. Now we shall show the formulation of a query and how it connects with the Cypher query. By clicking on New Node button, a user can view all node labels on the left panel. One can view a list of properties associated with a node label or creating a corresponding query node in the query canvas. The node is displayed as a labeled circle and a color is assigned to it dynamically by matching it with the color of the corresponding node label. When one clicks on a labeled query node, a sidebar pops up on the left of the screen, showing a list of properties that can be considered for predicates as well as a list of labels of possible targets. These targets are node labels that are connected to the query node label in the underlying property graph. We can add a target node on the query canvas in 2 ways. First, one may click on one of the target in the list of labels. Alternatively, one may add a target node in the same way as we create a labeled or unlabeled query node. After a node pair is added, we can then draw an edge, shown as arrow, by dragging the cursor from source to target node. Clicking on the edge displays in the left panel a drop-down list of all possible relationship types between these node pairs. One can optionally select a relevant type. We add some more nodes and relationships now. One can simply click on a query node and select a property from the displayed property list on the left panel to add a predicate. A predicate circle appears along the circumference of the node to visually represent it in the form of composite circle. This circle is filled with the same color as the property color, generated dynamically, allowing a user to easily associate it with its property. Next, one can fill in the operator and value associated with the predicate by selecting from drop-down lists. One can add multiple predicates on a single property or on multiple properties of a node. Note that the small circle of property with multiple predicates is larger than single predict property. Furthermore, observe that the customer node is larger than the order node, indicating that a larger number of predicates is imposed on the former compared to the latter. Predicates related to a relationship can be added in the same way. To delete any node or edge or predicate, one can simply select the component by clicking on it, followed by pressing the backspace or delete key. A user can mark the node that should be returned in the results by simply double-clicking on the corresponding query node and confirming it to be a return node through a dialog box. A return node is depicted with a bold circle. A visually formulated query in Sierra can be transformed to the corresponding Cypher query on the right panel. A user can copy the query and execute it with any state-of-the-art query engine. Furthermore, a user can also paste a query to the text box in Sierra and click Translate. The query will be translated by Sierra and transformed to a visual representation on the middle panel. In conclusion, Sierra based on LCG not only supports richer features compared to LAG but also embraces multiple principles and theories to create more usable and aesthetic query interfaces. Thanks for watching the video.